Good morning, friends. I, Mohit Goswami, on behalf of Institute of Language Teaching English Medium B.Ed College Rajkot, welcome you all in the Programmed Learning Part 2. Previously, we had discussed what is programmed learning and characteristics of programmed learning. Today, we are going to learn types of programmed learning in detail. So, let's start the lesson. Now, let's have a look at types of programmed learning. There are mainly three types of programmed learning: linear programming, branching program, and mathematics. The first is linear program. Many of us might be very familiar with the linear programming method of programmed learning, as it is very common in teaching. Linear programming is based on programming ideas put forth by B.F. Skinner. In a linear program, the subject matter is divided into quite small pieces of knowledge, which are generally known as frames. Each learner is taken through these frames in small steps and in the same sequence along a single path or line. So, linear program will go like this. The first slide, then the second, then third. Each learner will have to pass through all the slides or frames. Student's response to the first frame is immediately confirmed before he goes to the second frame. So whenever the student is going to the second frame, will be known his true answer over there in the second frame. The correct response to the previous frame appears alongside the forthcoming frame. The program is so structured that the probability of correct response becomes sufficiently high. Linear programs can be produced in book form for use on a linear teaching machine. This is a type of linear programming, and this is what we called frame. This is the first frame. As we can see that there is some content over there in the first frame, and there is a question over there. The student need to read the content first, and then they have to choose the true answer from the given options, and then he can go to the second frame. And as we can see that in the very first start of the second frame, the student will be having the true answer of the above question. Then he can make sure that his answer is true. And if his answer is true, then he can go to the next frame. If the answer is wrong, then he should go to the first frame again to revise the content. And in this sequence, the student will learn the thing. Now it's time to test your grasp for linear program. The proponent of linear program is blank. Yes, it is B.F. Skinner. The second question is the reinforcement blank, the tendency to give response. Yes, it increases the tendency to give response. Whenever the students are reinforced, then the tendency to give response will be increased. The linear program is also called blank programming. Yes, it is also called as extrinsic programming. The second name of the linear program is extrinsic program. In a linear program, the learner blank skip over the frames. Yes, the learner cannot skip over the frames in linear programming. Every learner must go through each of the frames. They cannot skip any single frame. The next is, in a linear program, the reinforcement blank quick. Yes, it is quick. As we have seen in an example that in the very first line of the second frame, the student will be known the true answer of the above question, and that will work as reinforcement. Cheating is discouraged by blank the answers. Yes, revealing. If the students are known that they will be given the true answer in the second frame, they won't look in the side students. So cheating is discouraged over here. The last one is, the emphasis in a linear program is on blank. Yes, students' response is focused over here. So the more emphasis is given to the response instead of stimulus. The next is branching program. The branching or intrinsic approach to programming was devised by Norman A. Crowder. He has defined branching program as program which adapts to the needs of the students without the medium of an extrinsic device such as computer. So here, extrinsic devices such as computer, mobile, laptop, tablet that are not needed. The student is given material to be learned in logical units such as linear programming. The units are much larger than those used in the linear programming. We had seen that in linear programming, the frames are very small in content. But here, unlike linear programming, the units are much larger. Each material unit is followed by multiple choice answers, from which the student is required to choose the answer which appears correct to him. According to the item which he has chosen, he is directed to different parts of the program to check his answer. If his answer is correct, the student is put on the main line on the program the same way as it happens in the linear program. But if he fails to choose the correct answer, the preceding unit of information is reviewed, the nature and cause of his error explained, and he is either returned to the original unit of the information or branched along a subsequence which give additional information to correct himself. So here the branching program is different from the linear program. If student fails to choose the correct answer, then he will be redirected to subframes to correct his error. So in branching program, if the student is responding true, then it will be same as linear program. But if he fails to choose the correct answer, then he will be redirected to subframes of the unit. He is then put to a retest before he is made to return to the main line. Let's understand this with an example. We will compare here linear program with branching program. In linear program, the students will be redirected to the first frame. There, he will be having content which will be very low. The difficulty value will be very low. He will be having a question over there. Then he will be directed to the next frame. There, at the very first line of the second frame, he will be knowing whether his answer is true or false. He can check his answer and then he will be having the second frame. And in the same way, he will be having the next frames. in the same line. While in branching program, the student is directed to the first frame. Here the content will be larger than the linear program. You will be having some questions over there, just like linear program. If his answer is true, then he will be directed to the next frame, same as linear program. But if his answer is false, then he will either be directed to the first frame or he will be redirected to the subframes of the unit to correct his answer. And after correcting his mistake, he will again be redirected to the main line. So this is the main difference between linear program and branching program. Now it's again a time to test your grasp of branching program. The branching program was originated by blank. Norman Crowder. Then in branching programming, the frame size is blank than that of linear programming. Exactly, it will be larger than the linear programming. In a branching program, the learner blank skip over the frames. The learner can skip over the frames. If his answer is true, then the subframes will be skipped by the learner. The branching program is also called blank programming. It is also called intrinsic program because no such extrinsic devices such as computer, laptop, mobile are needed over there. In a branching program, the assumption is that the learners learn by blank the errors. Exactly, by making errors. Because if the learner makes error, then he will be redirected to the subframes which are already made. So the assumption is that learner will make the errors and learn the topic. The branching method blank provide infinite branching to take care of all individuals. Yes, the answer is cannot. The branching method cannot provide infinite branching to take care of all individuals. So there will be 2 or 3 subframes which the learner can revise if he is answering false. But there can't be infinite branching to take care of all individuals. The third and the last type of programmed learning is mathematics. As we can see in the name, mathematics is more useful for the subjects like maths, physics and that. We will go here with inductive approach. So we will go with the examples first and then we will go with the theory. So we are having frames for a mathematics program to understand the square of 2-digit numbers ending with 5. So our first frame is to find the square of a 2-digit number ending with 5. So these are the steps which you have to follow to have the answer. Multiply the first digit by the next consecutive number. Then you have to write 25 to the right of the result. So in the first frame, the learner will be informed what he has to do to solve the problem. The second frame, to find the square of 35. So here we are having an example. Multiply the first digit, which is 3, by the next consecutive number, which will be 4. So here, which information was given in the last frame? The learner needs to put that in practice. Next, write 25 to the right of the result. So the result is 3 into 4, 12. So you have to put 25 to the right of the result, that is 12. So the square of 35 is 1225. The third frame will be another example. To find the square of 25, here the pace will be little faster. Multiply the first digit, which is 2, by the next consecutive number, which is 3. 2 into 3, the answer will be 6. In the next step, you have to write 25 to the right of the result. So the answer will be 625. The square of 25 is 625. We are having another example. To find the square of 75. Multiply the first digit 7 by the next consecutive number. You have to write 25 to the 7 into 8 is equal to 56. You have to write it to the right of the result, not to the left. The square of 75 is 2556. To find the square of 15, multiply 1 by 2. Write the answer, that is 2, to the right of the result. So the square of 15 is 225. 1 into 2 is equal to 2. Write 25 to the right of 2. So the answer is 225. And now it is for practice. What is the square of 65? You have to calculate. Then for 95. Again, we are having some more examples. What is the square of 65? The answer will be 16 to 7, that is 42. And to the right, we will write 25. So 4225. And for 95, 9 into 10, 90. To the right, we will write 25. So the answer will be 9025. So this is the example of mathematics type programmed learning. Now let's move forward the theory. Thomas Gilbert introduced mathematics in his article Mathematics, the Technology of Education. The term itself has been derived from the Greek mathein, meaning to learn. Mathematics is defined as the systematic application of reinforcement theory to the analysis and construction of complex repertoires, which represents mastery of subject matter. The unit for a mathematical program sequence is called exercise. There are no restrictions on its size or extent, unlike linear programming. Here there are no such restrictions for its size, that it must be smaller or larger. It can be any of size. The main consideration in this case, however, is to have as big an exercise as the student can reasonably take at a moment. So the size of the exercise must be bigger over here because it is more helpful for practical subjects like maths and physics. So the exercise will be more emphasized. The steps involved in mathematics are mainly three. The first is demonstrate, in which the programmer demonstrates the introductory frame, which is the mastery frame. In the above example, the first and the second frames were demonstration frames, where the programmer has demonstrated what to do to solve that problem. The second is prompts, that are used in teaching frames to help the learner to give the desired response. In the example, third to fifth frames were prompts. And the last one is the testing frame. The last in the sequence is a release frame, where no prompts are given. So here the learner won't having any help from the programmer, just as we had seen in the sixth frame. Only the questions were there and answers were there. So no outer help will be provided to the learner in the release frame. So the sixth frame was release frame. Here we are ending our topic programmed learning. Thank you very much.